Hi, chemistry. How's it going? I know that a lot of you had some AP exams last week, and a few of you have some more AP exams this week. So I've been keeping it kind of light. We've only covered one section, actually less than one section, between last week and this week. So by the end of this week, I'm hoping you'll be ready to take a quiz that you have that's assigned to you in Google Classroom. It'll be on chapter 14, section 2. I've got my little 2 here. There we go. And most of that. Pay attention to the page numbers that I ask you to read in your homework assignments in your book, because that cuts off at page 486, because I don't need you to know any of section 2 beyond page 486. That will not be on your quiz. So pretty light these past couple weeks. I hope that you are thankful for some extra time to study for your APs if you're up against them last week and this week. So just as a little bit of a review, what you're going to see on your quiz. You're going to see stuff we learned last week, 14.2a, and that's the molarity equation, where we define molarity, capital M, even though sometimes they name molarity with a lowercase m in your book, and that's standard, but it's represented with a capital M. It's moles of solute over liters of solution. So remember, we talked about the fact that this was solution, and that's the total liters of the entire solution. So they'll usually give some of that in your problem, but sometimes they'll give it to you in milliliters. So units is a big thing you have to watch out for. So if I throw that on your quiz, make sure you know how to convert from milliliters to liters and back again, because your molarity equation is always, always, always in liters for the unit on the bottom. Another thing that I showed you last week is that sometimes they give you grams of solute instead of the moles of solute. So you have to figure out, how many moles are in that amount of grams that they gave you in the problem. And this is very common in chemistry, which is why I'm getting you guys to practice this, because typically when you scoop out a chemical, you can go weigh it and know how many grams of that chemical you have. You don't know right off the bat how many moles that is. It usually requires a calculation. So this is a very practical lab type calculation that you really need to be familiar with to be a good chemist. So how do we get from grams to moles? Well, we use stoichiometry. So those of you who are a little weaker in the stoichiometry might want to rewatch that video that I put up last week and make sure that you understand how to do a problem like this. This is my notes from last week, so no need to copy this down a second time unless you want to push pause and just try it out again for good practice for your quiz. But here's your molarity equation again from the first half of section 2 in chapter 14. What if they give you grams? Well, before you use this equation, you've got to be in moles. So you take grams on the top, grams on the bottom, use your periodic table to calculate the molar mass, and voila, you have moles that you can now fit into this equation legitimately. This problem also use milliliters, so you have to convert milliliters to liters, and that's by moving over your decimal boop, 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 3 times. So 2.364 liters is 2,364 milliliters. So again, something else to watch out for your denominator is to make sure you're in liters. Then you can finally use your molarity equation, divide them out, and get the molarity with a capital M as your unit, which is moles per liters. So that's pretty standard in chemistry. So I hope you pause that if you felt a little weaker on that concept and just try it out again, because practicing these is what's really going to help you to get these right on your quiz. So that was last week. This is this week. We're going to work with the dilution equation, and I'll show you that formula now and then update this sheet. So save a little space if you're pushing pause to copy these quiz review notes down, because we'll get that equation in here by the end of this session. So today's lesson is on diluting molar solutions. So in the lab, it's really typical for a chemist to keep around a super concentrated stock of a solution. This could be like a salt solution if they're doing a lot of biology or microbiology, if they're just dealing more with like inorganic chemistry, then this could be like a solution of calcium or something like that. Okay, so you have this in here, and it's really really concentrated. But then chemists just take out a little bit of it and they dilute it in order to use it in their reactions. So if they kept a whole bunch of this around and they needed to get to something more like this, which you can tell a little bit in my camera, that's way more diluted than the first one. There's both green, but this one's like super dark green, almost like black looking, but this one's really green. So how do I get from this super concentrated to this, which is not so concentrated? And the answer to that question is just add some water. If this water is the solvent, in this case, in this test tube, then if I add some water to this test tube, I could make it a dilute test tube like this one. So 2 test tubes, same solute, same solvent, but one's more concentrated than the other. And how do you dilute it is the question of the second half of 14.2 in order to use it in a reaction that you want to use not so concentrated, because lots of lab experiments require a diluted concentration of something, not a concentrated concentration of something. So our dilution equation simply tells us that if you have initial molarity m sub 1 and an initial volume m sub 2, then you can dilute it to a smaller m sub 2 by using a bigger v sub 2, which is increasing the volume, which basically means adding more water to a stock like this to make it less concentrated into a stock like this that I can then use in a chemical reaction. So notice the math on that. If you have an initial m and v, you have a final m and v, but notice these are equal. So if this goes down, then this must go up. And that makes logical sense to our minds, because in order to dilute something, lower molarity, you need to increase the volume, higher volume. So these, this math just kind of works itself out really nicely. All right, let me put up a practice problem. So here's a nice practice problem. What volume in milliliters, notice that they are expecting a certain unit for the answer, we'll think about that at the end, of a 1.15 molar stock solution of potassium nitrate is needed to make 0.75 liters of a 0.578 molar potassium nitrate. And so in working out this problem, you want to identify your variables right off the bat so you know what you're looking for. In this question, it starts off with what volume? I'm not exactly sure which volume that is, if that's V1 or V2, so I'm just going to put like a question mark by that one for now. And thinking about, that might be one of my volumes. Of a 1.15 molar stock solution. Now your stock solution is always going to be the higher number, so that's always your m sub 1. So I put a little m1 there. Potassium nitrate is needed to make 0.75 liters. Now that's what we're making, so that's got to be V2, which then tells me that this one's V1. We're trying to figure out how much of our initial volume, our initial stock solution, to make a final stock solution. So our answer should probably be something smaller than this number, because our stock solution is going to be a smaller volume. We dilute it, it's going to turn into a bigger number. And then we have a molarity of potassium nitrate. So that's going to be M2, because that's the desired molarity for the experiment we want to do. So if that's the initial molarity, you can see it got more dilute to a smaller value of molarity. So if V1 is the thing, it says what volume that we're trying to solve for, then I need to take this equation and solve for V1. So to get V1 by itself, oops, that's a little whiteout action here, just so you can see for sure that that's V1. Okay, so how much volume? So solve for V1, I need to get V sub 1 by itself, divide out the M sub 1, because these are being multiplied. We undo that with division. And what you do to one side, you do to the other side, that cancels. Voila, we've got our equation that we need to work with. Plug in your numbers. We got M2, 0.578 molar. Sometimes well, always put your units in there. V2 is 0.75. Yep. And yep, just 2 sig figs for that one. Okay, and the last one, M1, put that in there. 1.5 molar. And I could put parentheses around that, but it's not really necessary. Okay, notice your molar crosses off, and you got your answer in liters, which is good because I needed a volume as my answer. So throw that in your calculator, try it out. I hope you tried that in your calculator. Make sure your calculator is good. And I got 0.38 liters. I just realized my picture might cut that off. So let me write it again down here. But our answer or question asks for what volume in milliliters. So you have to move your decimal over to make this a bigger number because you have a smaller unit. So 0.38 is actually turns into 380 milliliters for the final answer here. So we got our volume in milliliters of this solution. So that's what you're going to see in some of the problems you have there. Again, you will see some review problems in your 14.2b homework. I thought that throwing in some questions from the initial part of 14.2 might be helpful in reviewing for your quiz, which is due by Friday. So let's take a quick break from the math so I can show you a volumetric flask, which is often used to make stock solutions. Notice this volumetric flask says 1,000 milliliters. What's that? Oh yeah, that's 1 liter. So you can kind of see, compared to the size of my hands, how big this volumetric flask is. Now, if you fill this up exactly to this line, which is a little hard to see because there's some stains, but it's right here. Can you see that line right there? If you fill it to exactly that, you have a 1 liter or 1,000 milliliters of your solution. So the way you make a stock solution is you start to fill up this volumetric flask, maybe to about here, and then you add the solid, maybe like salt or sugar or whatever your solute is, to the flask, because you don't really know how much space a solid's going to take up when it dilutes water. So you fill it up only to a little bit, maybe here, pour in your solid, and then once you know you have exactly the amount of solid that you need to make a 1 molar solution, since this is a liter, this is a pretty common size for a volumetric flask, then you continue filling it up with your solvent, which would probably be water, all the way up to this line. So that way you know you have exactly the solid you want in here and exactly the total volume you want in here, and then you'd go ahead and mix it up for your 1 liter solution. Now, why are those steps important? Well, what if you filled it up to a liter and then you dumped in your solid? Oh yeah, that's going to make your total volume go up above that line, above 1 liter, and then your solution is no longer accurate to be 1 molar solution. So you have to fill it up partway, add your solid, that brings up the volume a little bit, and then add the rest of your volume of your solvent to that line exactly, making your total 1 liter solution here with your volumetric flask. So your book talks a little bit about that. I hope you take the time to read your textbook on that quick section. All right, how many of you feel like you want one more problem just to practice to make sure we're good for our quiz? Oh, look, I saw a hand. All right, here we go. And here it is. So push pause and try it out. As I'm looking at this, let's identify some variables. If 55 milliliters of a stock solution is diluted. So these are both my initial values. Here's an M1 and a V1, because I know exactly how much of my stock solution. Now that's 2.45 molar, that's pretty concentrated. 1 molar solutions are considered pretty concentrated, but 2.45, that's really concentrated. I've seen numbers of up to like 10, 20 molar, but those are super concentrated of something. So dilute it with water to make 168 mils of sucrose solution. So maybe this is an experiment where you're looking at cells, they got to eat sucrose, and you have to think, I need exactly 168 mils of sucrose. So, I need to know how much of my stock solution to use in my experiment. We're going to make this one as the final volume. And the question is, what is the molarity of the final solution? So that's a big hint. Final solution, that's your M sub 2. So it looks like my M sub 2, what is the molarity, is my question mark in this problem. So set this up. and we're solving for m sub 2. If we want m sub 2 by itself, v2 is in the way. Divide it out, cross it off. So therefore we only have m sub 2 in our equation here. Some of you like to put the unknown on this side, so if you want to at this point, you can flip-flop your equal sign. Not really necessary. I like less steps, the better. You guys know me. So just go ahead and throw your numbers in here. M1 is 2.45. V1 is 55. And V2 is 168. And it's worth pausing for a moment here to notice that I didn't bother converting my milliliters to liters. That's because as you work out this problem, they automatically cancel. And so you can, if you want to, as a safety step, always convert to liters. That would give you 0.055 liters and 0.168 liters, and you'll find that if you divide out those numbers, you'll get the exact same answer as if you just did 55 over 168. So in this case, it's not important to convert to milliliters. However, in your molarity equation, which was from section 1, it's very important that your bottom unit be in liters because that's part of the definition of the equation. So, knowing when you have to and when you don't have to be in liters is kind of a concept you pick up as you do more and more chemistry. But for safety measures, as long as you're showing your units, things should cancel. And if they don't, you got to rethink, wait, maybe I needed to be in liters. That works with Kelvin too. If you're like Fahrenheits and stuff don't cancel out, like, oh yeah, I need to be in Kelvin. So, those kind of things will lead you down the right path, showing your units. So throw that in your calculator. And here's what I got. I hope you tried this out too. 0.802. This time we had 3 sig figs and everything. 3, 3, 3. So our final answer can have 3 sig figs. Don't forget your unit. Those are some of you are getting like half points off on your quizzes and tests for forgetting units. So don't forget those units. And you should be good to go for the rest of this section. All right, let's just go back to the quiz review for a moment. Remember, we had molarity equation. You're going to see something like this on your quiz where you have to calculate this. Make sure that is in liters. If you're given grams, you got to use the stoichiometry to convert to moles before using this equation. Dilutions was as easy as M1V1 equals M2V2. And use your units all along the way just to make sure the right units that they ask for are something you convert to at the end. Common misconceptions in these problems, especially this one, don't mix up your 1 and your 2 and your 1 and your 2 here. Make sure you pay close attention to the wording of the problems to make sure that you don't mix these up. Read carefully. Make sure you know which one's your stock, those are your 1s, and which ones are your final solution. Those are your sub 2s. Usually your stock numbers are bigger number, by the way. Bigger number here, lower number here. For your volume, usually the lower number is here and your bigger number is here, because remember, you have to add water to get from a more concentrated solution to a less concentrated solution. All right, that was a lot of words. I hope you guys work this out and feel confident going into your quiz this week. That's the last of what we'll cover the school year, because next week is dead week. So, hey, good job, you guys, pushing forward through the end of the year. You'll get a study guide next week for dead week. Bye.